machines. I'd like to hear your experiences of working with simple machines, or where you may have seen a simple machine in your world.
Define simple machine.
Simple machine, great. Okay, so I know you all came prepared with your science notebooks, and we should probably take some notes on what a simple machine is. Does anybody in here want to answer that? What a simple machine is? Yes?
That isn't like a simple machine. Isn't like a lever a simple machine?
A lever is one.
Lever.
And that's the one we're going to be working with today.
Okay.
There are 6 or 7 simple machines depending on who you ask. And we'll talk about the other ones another day. But today we're going to talk about levers. Have you guys ever ridden on a lever?
Now I've switched the lever.
Anybody been to a playground that has a teeter-totter?
Oh, yeah.
What's a teeter-totter?
It's a
It's
lever.
a lever, right? Because it looks like this. And somewhere it's got like the point where it pivots. Does
Yeah.
anyone know what that's called?
The bolt.
It starts with an F.
The fractals.
Fulcrum, great.
I didn't learn this. You learned this last year. I've heard this
Okay,
fractal.
so you got a kid sitting here and a kid sitting here, right?
And if the fat kid weighs more, then it goes up higher.
Exactly. So if you're with at the park with someone who weighs more than you, is there something you can do on the teeter-totter?
Well,
You might jump off.
How you can change your teeter-totter system to make it easier to lift the object or to make it harder to lift the object. So I'm going to pass this out and you can experiment for a few minutes. So there's your teeter-totter, there's your fulcrum, there's your child.
there's the other child.
We just have one child. Your finger will be the other child. What are you guys finding? Is there a pattern or a relationship
Sure.
between having the fulcrum at one place?
Yeah.
What are you finding?
Well, like they said, like if you move it farther away, then it's harder to like get the guy up in the air
So how can we make it easier?
by like moving it over here, I guess.
Okay, so closer to the
Closer
load.
to the load, yeah.
Excellent. Okay, so I put a graphic organizer type of thing here on the board, and it says lever patterns. Move the fulcrum blank to make work easier. Move the fulcrum blank to make work harder. So think about that, and I'd like to look at your notes if I can, what you have so far.
I'm not done for this.
Simple machines. Okay, so Hope, I'd like you to on the bottom half of your page, write down what you would do if you were with a friend that was a lot lighter than you. How could you two teeter-totter successfully? And you can't move the fulcrum,
It's in the ground.
so maybe let's experiment now with leaving the fulcrum in one place and moving our finger.
Okay.
Let's see what you have in your notes.
Oh, Luke was writing that.
Will you turn them toward me so I can see?
Changed.
Thank you.
There you go, right there.
I only got that far.
You're just thinking.
Moving the fulcrum changed what?
Like
The
how hard it was to get this little box like up in the air, I guess.
Okay, cool. Come up and complete the top section of the graphic organizer. When they're finished, if you'll complete the bottom section of the graphic organizer. And we're all copying this down in our notebooks before we leave today. So, lever patterns. Moving the fulcrum blank. Move the fulcrum blank to make work easier. So we're gonna either say closer or farther from the load, to the load. And if you need to experiment again, you can. Moving the fulcrum. I'll put this up here while you're thinking about it, so you can see. So I think what you told me earlier is moving the fulcrum closer to the load makes work easier. Is that easier? So you're going to want to write closer. That's great. Okay, thank you. So boys, this should be easy. Since they already talked about moving it closer. All right, and one thing I want you to notice, so here we just have two words like closer and farther, but in your system, it's not just closer or farther, right? There are different little steps, right? There are different distances that you could move this fulcrum. You could have it here or here or here or here. It's not just closer or farther, right? So do you think easier, harder? Is this going to be a lot easier, and this is maybe somewhat easier? Well, and this is like not very much easier.
Yeah, it's like, no.
So it's like a spectrum or on a scale. So there's a pattern there, and the relationship is as we move the fulcrum, the work difficulty changes that same amount, right? And we'll get into the math tomorrow. There's math that goes with this on how we can predict what our lever's going to do. But good job today designing your system and taking notes on what those patterns are and what they mean. As you can see, we wanted to look at forces and how they act on simple machines. We were able to do that. We were able to build our own lever simple machine. We found the patterns in the what we call input and output. Input is your finger. The output is the paper clips or the little person getting a ride on the lever. And we tested our own lever system, and you recorded your observations and data. So very good. Nice job today. Please make sure you all have this written in your notebook before you leave. Thank you. The end of another very successful lesson. So good to be me.